STEM activities at NIST today. But I wanted to just comment on the two young people who spoke, Alex and Takia. They're just amazing. It never ceases to amaze me how young these people are and how young they start now. I guess they have to start this young. And what a head start they had. And so that's thank you for your talk, please, Alex. And just want to tell Alex that engineering and science, more than 50% of the time we fail. So you hit it on the spot. That's what research is all about. And where's the key? Oh, well, see you at NIST. I saw a bus last week in front of the buildings picking up the service connection. I'm sure you were one of them. So that's amazing. Great talk. So as Uche mentioned, my name is Ben Tsai, and for the past 20 years, I've been privileged to work at NIST, or the National Institute of Standards and Technology, and to be part of serving our nation in exciting research projects, in calibration of primary instrumentation, and also in the education and public dissemination of knowledge to the scientific community. Also, for the past 15 years, I've been privileged to teach part-time at Montgomery College here in the Department of Physics, Geosciences, and Engineering. And through this wonderful opportunity of being able to teach here, I've been able to maintain my teaching skills and my engineering fundamentals, and while also engaging in the education of some very remarkable young and some older students in the engineering programs. So because I'm in a unique situation to be part of these two remarkable institutions, these wonderful institutions, I've been able to share some of NIST with MC, and I've also found some ways to share part of MC with NIST, as I will share. So tonight I want to talk to you about what NIST is and what NIST does. And then I want to discuss with you about what STEM is, briefly. I think most of you know what that is. And some of the many ways that NIST is involved in STEM efforts. So, first, NIST is a non-regulatory federal agency within the U.S. Department of Commerce. NIST employs about 3,000 scientists, engineers, technicians, administrative and personnel. NIST also sponsors about 2,700 associates from academia, from industry, from other government agencies, who collaborate with NIST staff and also access some of the user facilities that are in NIST. And NIST also partners with about 1,300 manufacturing specialists spread over 400 MEP centers, and I'll talk about MEP at the bottom there. So NIST tries to achieve this mission in one of three ways. First, NIST laboratories, which conduct the world-class research, often in collaboration with industry. And second, the Baldrige Performance Excellence Program, which emphasizes performance excellence among U.S. companies. And also it administers the famous Malcolm Baldrige National Quality Award every year. I think the President of the United States gives that out to several companies. And third, through the Hollings Manufacturing Extension Partnership, which is basically a nationwide network of people who help small U.S. businesses achieve their goals and become competitive. So NIST has two campuses. The main one here is in Gaithersburg, which some or many of you have been to, by 270 and Copper Road there. The other main campus is in Boulder, Colorado, which is also pretty nice. They're a little smaller. They have about 800 employees there. NIST also has 4 joint institutes, one called JILO out in Colorado, one called the Biotech Institute, and the Joint Quantum Institute, both at the University of Maryland, and the Hollings Marine Laboratory in Charleston. So we have NIST staff at each of these locations. NIST also has very unique scientific facilities. One's called the Advanced Measurement Laboratory. If you'll find in these laboratories the state-of-the-art facilities with very tight temperature, humidity, and vibration control. The Center for Nanoscale Science and Technology features some of the best clean rooms where they do advanced semiconductor research. And then here we see the NIST Center for Neutron Research. Every year, this center allows a lot of users to come and use their beamlines to perform research in many different areas, including chemical physics, neutron physics, and medicine. And then just last month, or 2 months ago, the MC, Community College Robotics Club, came to NIST for its first ever tour of our new NIST robot test facility. So those of you who are into robotics, you ever want a tour of that? It just opened this last month. So I think I had some fun. Is Dr. Bull here tonight?
It's supposed to be. It's not here yet.
Okay. He came with us. So. Okay, and I'm privileged to work at an institution like NIST, which has a long tradition of top-notch scientists. During the last 16 years, just within the last 16 years, NIST has produced 4 Nobel laureates in physics, in addition to the many international and national awards. By the way, the last 2 here, Professor, well, they're women. They are doing things. Women do make a difference. So the latest example is David Wineland. He's out in Boulder, NIST Boulder, and he won the Nobel Prize in Physics. Was one of the 2 who won it in 2012. He, along with Sergei Haroche of France, they together won the Nobel Prize in Physics for developing a model or developing something that's equivalent to a super fast computer based on quantum physics. And their research also is leading to the development of precise, very precise, super precise clocks, as I will show you. The mission of NIST is to promote U.S. innovation and industrial competitiveness by advancing measurement science, standards, and technology in ways that, and here's the important part, so don't forget this part, enhance economic security and improve our quality of life. So the last 2 phrases are actually the most important, because without them, then this would just be a science lab. But actually, this is much more than that. So the concept of standards goes way back to the history, the beginning of our country here. George Washington emphasized the uniformity in the currency, weights, and measures of the United States. And the U.S. Constitution accorded, the U.S. Constitution says that the Congress shall have power to fix the standard of weights and measures. So this, we have our mission from way back, over 200 years ago. However, it wasn't until 1901 that President William McKinley, the President of the United States at that time, appointed Samuel Stratton to be the first director. And the state of standards at that time was really messy. And as an example, if you guys can count how many rows in this table, at that time there were at least 17, count them, 17 standards for the unit of gallon. You know what a gallon is? Okay. So think if you bought a gallon of milk, and you only got 3.5 liters, and then somebody else got 4.6 liters, wouldn't you feel kind of cheated? So that's why at that time, this is the say now, the U.S. gallon ended up right there, the first one in blue. But there was a lot of work to do in 1901 at that time, at the turn of the century. So the U.S. Constitution in 1787 gave Congress the authority to create relevant standards. But as I said, it wasn't until 1901 that Congress actually passed a law to create NBS, which is called the National Bureau of Standards. So that's what we started as in 1901. And in 1988, you can't read that, but in this little quote there, in 1988, Congress changed the name of NBS to NIST, which is what we are now. And that stands for the National Institute of Standards and Technology, adding to us the specific responsibility to help technology, U.S. technology, especially for the small U.S. businesses. This, as I mentioned, is part of the Department of Commerce with a presidential appointee as the director. Currently, Rebecca Blank is our acting Commerce Secretary. So if any of you are interested in that job, please apply to us. And then Patrick Gallagher is the NIST director. Within NIST, we have currently 6 laboratories. I want to briefly mention them. The material measurement, in case any of you are interested in coming to visit, or maybe work there in the future. The material measurement laboratory has chemistry and materials labs. The physical measurement laboratory, which has physics and electrical engineering labs. The engineering laboratory, which has engineering and manufacturing labs. And then the IT, or Information Technology Laboratory. The Center for Nanoscale Science and Technology, which has the nanotechnology labs, and the NIST Center for Neutron Research, which has the neutron facility I just mentioned. So you can see a couple examples from each of the laboratory, the research projects there that I listed. Now I work in the Physical Measurement Laboratory, which is further divided into 8 divisions. And some of our divisions include like the Semiconductor Division, which does the semiconductor research, and the Time and Frequency Division, which is responsible for the U.S. National Standard of Time. And I'll talk about that a lot more in a little bit. So the Sensor Science Division, where I work, that's the division I belong to, has 4 different missions. Every division and NIST has their mission. So this is the mission statement. And basically, the mission of our division is to maintain the standards for the SI base units of Kelvin and Candela. Those 2 we have responsibility in our division over. And NIST has responsibility over all the SI units. Okay, 7 of them. There's 7 SI units, and then a lot of derived units. And so somebody at NIST is working on maintaining the standards for each of those 7 units. Okay, so I won't ask you now, but I hope each one of you know what the 7 base units are for SI. We're also responsible for various optical, humidity, pressure, vacuum, and flow quantities. We try to advance applications in all these technology areas, especially ones that are important to the national security, including climate change, greenhouse gases, a lot of other ones. And then we try to build an measurement infrastructure so that we can meet the emerging needs of all these measurements. And last, we support international efforts and activities, like inter-comparisons with other labs and other companies, so that we can basically get everybody to support NIST in our measurements of these products. Okay. In our division, there's a lot of research done and a lot of calibration done in many different areas. I listed here, but basically areas covering spectroradiometry, photometry, and thermodynamics. Now, and NIST, I've been able to work on a lot of exciting projects, but 3 of them I want to highlight here and share with you. I worked on the measurement, remote measurement of silicon wafer temperatures and semiconductors using something called sapphire light pipes. And that was an exciting project that I was able to work on. I also worked on measurement of reflectance and transmittance for diffuse standards for the remote sensing community. And then over there, you'll see a picture of a spectrograph. We did some work with a spectrograph which measures temperature as a function of space, x and y, and also as a function of wavelength. Okay? A lot of data. And that's useful. That one in particular was to help the fire firefighting missions. Now, so what do we do at NIST? I just wanted to show you very quickly some of the exciting things, and most of these things I know nothing about. We know very little about them. We hear about them all the time. So I'm going to share with you and just list some of these things for you to show you a sampling of what exciting things that NIST is working on. And I think Takia probably could tell you some more too. So first buzzword, the first thing is called nanotechnology. So nanotechnology involves research dealing with things that have components and features that are less than 100 nanometers. Okay, so everybody knows what nanometer is, right? Okay, so that it's a very small unit. So a nanometer is a thousandth of a micron, and micron is a thousandth of a millimeter. So if you take a millimeter and you divide it into a million parts, that's 1 nanometer. So take a millimeter, divide in 10,000 parts, and we're talking about things that are smaller than that. So a lot of people are working on this because it's useful and it improves a lot of things that we have today. Another activity that NIST does is we respond to urgent national needs. So here, let me give you 2 examples. First, 9/11. Okay, who was alive during that? Some of you were. Some of you remember? Okay, so at 9/11, NIST after the incident, NIST was able to conduct a very thorough research, which concluded in NIST recommending at least 30 major improvements in building codes, which most of them have been implemented, luckily, especially the new buildings that are being built in New York City and other major cities. The second is, I know you young people are too young for this, but because you can't vote yet, but starting a few elections ago, there were a lot of problems or issues with voting machines, electronic voting machines. And NIST had a big effort in writing the standards for the e-voting machine. Okay, so when you guys become 18, you get to go to these machines and choose who you want for president and other leaders. So NIST has something to do with that. One of the, I think NIST has a history of working on many different types of applications and areas, and they range from everything to everything. So from manufacturing and pharmaceuticals to law enforcement and biotechnology. So we just work on a lot of different areas and applications. So NIST, or MBS, when it's called MBS, has worked on the standard of time. So time is measured in seconds. Okay, everybody know that, right? Okay. Well, in 1949, the standard for measurement of time at MBS at that time was an ammonia resonator, and it was a clock that was accurate to 1 second in 300 years. Okay, 300 years is longer than most of our lifetimes, all of our lifetimes. We don't even live that long. Okay, so we can't even live that long to prove that we lost 1 second. But it was accurate to that long. Now, because of technological needs, NIST developed in 1993 the NIST 7 clock, which, get this now, loses 1 second in every 6 million years. But because the technological needs for time and frequency measurements were great, NIST came out with the NIST F1 clock in 1999, loses 1 second in every 60 million years. And of course, that's not enough, right? So, due to the advances in laser cooling and quantum physics and what the guys done in the Nobel Prizes at NIST, NIST is now working on developing the optical clock, okay? And it only loses 1 second in every 30 billion years. Most of us don't even need that. If our clock is accurate to a few minutes, we'll be happy, right? but because of frequency measurements, it actually is needed, okay? and other applications. So for those of you who have not yet synchronized your watches or your computer clocks to the U.S. National Standard of Time, please go home and bookmark your page to www.timesago. But actually, this is a pretty neat a website, and they have an app or a download that you can synchronize your computer clock with them. And it's accurate to within a few seconds, which is a transmission, has something to do with transmission. So it is actually a pretty good website. Now, NIST tries to help facilitate trade in the United States by instilling consumer confidence. It is estimated that in the U.S. alone, I think the trade accounts for over $5 trillion, okay, in money, which is a lot, right? So NIST is doing quite a few things to help facilitate trade, including improving the integrity of the financial transactions, like when you go to the ATM machines. Of course, maintaining the www.timegov website, which gets billions of hits every day. Okay? There are people who are syncing to it, which is good. And also working on things like the ATMs, and making sure they're secure. There are over 300,000 ATM machines. I think that's an old number, so there's probably a lot more now. And we use them every day. So we have to make sure they're secure and that there's standards written about them. As I mentioned in this mission statement, one of our main mission is to improve the quality of life, not only in the U.S., but all over the world. And so here are some examples of how this does that. We write standards for cholesterol, reference materials, try to improve the quality of drinking water. I think you'll appreciate that. Set the standards for sulfur and fossil fuels so we don't pollute the world more. We can minimize that. And also, we write standards and help in the research on prostate and breast cancer treatments. So, and then a few others. So we do really try to work on things that affect a lot of people in the world. We also have NIST tries to help improve public safety and security by working on things such as metal detectors, like when you go to the airport, wireless smoke detectors, which I hope everybody has in their house, right? And body armor, and a few other things. So there's a lot of, especially now, there are a lot more and more things that we work on in terms of security at NIST. Some things I can't talk about. Okay. NIST also tries to help advance manufacturing in the United States. Okay, and some of the things that they try, some areas include semiconductors, pharmaceuticals, drugs, chemicals, fuel cells, cars, healthcare. So there's a lot of areas that we're in. And so that's a short summary of what this does. So now I want to talk a little bit about STEM for the rest of my talk. And I was just at last month, I went to Parkland Magnet Middle School, which is where my daughter's going to go. And we attended a STEM night. And I was just amazed at all the things that they were doing. Every child had a poster telling us what they did during the year. The research projects were amazing. And also, I was even more impressed because that night, a few of the students, those who wanted to, and I'm sure some of the best students, stood up in front of the teacher and the classmates and gave a 10-minute PowerPoint presentation on their scientific research project. And I was just like blown away. I said, I wish I had that opportunity when I was in 7th grade. So it was great. I'm sure that's going on in a lot of places, especially around here. So the second thing I want to mention is an example at Montgomery College here. I was talking to Mr. McCulloch on the GT STEP program. And the GT STEP program, I'm going to read it because I don't remember what it stands for. But it stands for Graduate and Transfer Science, Technology and Engineering Mathematics Talent Expansion Program. Okay? But what I understand is Montgomery College got a grant to help the students here at MC to do two things. One is to improve their skills and abilities in the STEM classes. And second is to provide some internship opportunities and research opportunities for the students at Montgomery College. And I think that's just wonderful. and there's, I'm sure other things are, a lot of other things are going on at college, at this college and at the secondary schools everywhere around here. So, what does STEM stand for? Everybody already knows this. It stands for science, technology, engineering, and mathematics. Okay? Four of my favorite things. I hope your favorite things as well too. STEM actually can refer to the projects, the funding, and the programs that are offered by the Department of Education, the U.S. Department of Education, and the National Science Foundation. STEM can also refer to people who are skilled in these four areas, but at the very least, STEM is now on the U.S. public education agenda, which is, I think, is wonderful. So NIST offers a host of programs and activities that support STEM, the STEM effort. Some of these programs are geared towards elementary school and middle school and high school students. Others are prepared more for the undergraduate, graduate, and postgraduate students in college. So I'm going to share with you some of these STEM efforts at NIST that actually involve all of these guys, everybody, from you guys in middle school way up to after graduate school. Okay? So let's go. Here's a list of the activities, STEM activities that NIST has for secondary schools, that's elementary through high school. So I'm going to go talk about each of these separately right now with you. The first one is called the Adventures in Science program, and that one is offered on a weekly basis on weekends from October to March for kids 11 to 14 years old. Okay, are you guys listening? Okay. So if you're interested in this, on some Saturday, I think it's morning, for a few hours, if you're interested in science, ask your parents if they can enroll, and you get to meet, you get to do hands-on stuff with real scientists at NIST, and then also with other scientists from outside of NIST as well. Another STEM effort is called the NIST Summer Institute for Middle School Science teachers. Okay, so it's not for the kids, this is for the teachers. And this is a 2-week course that is 2-week training that's offered by NIST for middle school science and math teachers. And the teachers come to this 2 weeks and they have a very intensive 2 weeks of also hands-on demos and interaction with other science teachers and also with NIST staff. I think there's a small stipend that is given to the schools for the middle schools for sending their teachers to this activity. So those of you who are middle school science teachers, this is something that you might want to look into. Also, for the last 17 years, NIST has sponsored something, or co-sponsored something called the Science Gets Psyched for Girl Scouts. Every year until last year, over 300 Girl Scouts have come to NIST to participate in the activity. It's for juniors and cadets and Girl Scouts. The last one that took place was last March, 2012, and they were the Girl Scouts that came had the opportunity to participate in about 3 to 4 experiments. They watched a very exciting demo, and then they were able to ask questions to a panel of experts, which were all women scientists. Even though this wasn't, this event didn't take place this year because of organizational problems, this is still a great example of how NIST is helping in the STEM effort, which influences a lot of people, a lot of children. Another one of my favorite STEM effort activities is the annual NIST Take Our Daughters and Sons to Work Day, which is offered to the NIST employees' children from 9 to 14 years old. Includes lab tours and demos. Every year for the last, I don't know, 10, 12 years, I've taken one of my children, at least one of my children, to this Take Our Daughters and Sons to Work Day at NIST. And every year they really enjoyed it. not just because they miss school, but because to watch, to go to NIST. And although, I have to make a disclaimer, although most of my children have not ended up majoring in science or engineering in college, I personally believe that this exposure through these kind of efforts, especially this one, has had a great effect on their general education and has broadened their perspective of mind. So I think I do have one daughter that is majoring in chemical engineering. So the others have decided not to. Then the last ones that involve secondary schools is something called the Adopt a School Opportunities. And this is co-sponsored by NIST and the Montgomery County Public Schools. And basically involves career fairs, it involves homework clubs, and something else, and career days and science fairs. And this is just a subset of the examples of the various different schools of career days and all these other things that are happening at middle schools that encourage STEM. And I think somehow NIST is a co-sponsor or is involved in helping in at least these activities. Okay, so another major way that NIST is helping in the STEM effort is through student employment opportunities that occur in NIST. And something called the NIST Pathways program offers direct paths to sometimes to federal, to working in the federal government. Includes three types of programs: the internship program, which I'll talk about, the recent graduate program, and the presidential management fellows program. NIST also has has several classes of volunteer, non-paid positions, including the student volunteer program and the SHIP program, which I'll talk about. And then finally, there's also these other programs I want to talk about: the CERT, the graduate student program, and this postdoc program and the postdoc. So first, the pathways. The internship program is for students who are now in school, but you have to be 16 or older, so in high school. And these are paid opportunities to work part-time at NIST while you're enrolled in school. You have to be half-time enrolled in school. But it is also for college, so it's high school or college students. And another program, the recent graduate program, is for those who have graduated with an undergraduate degree in a college like here. And so these are opportunities at NIST for those people who just graduated from college to also work at NIST. And this is even further down the road. These are for people with an advanced degree, so people with a graduate degree, a master's degree, or a PhD. They are 2-year positions, and they're also paid, and there are opportunities to try working at NIST. As far as volunteer positions, there's a lot of opportunities to volunteer. And one way, the general way, is through the student volunteer program. You also have to be enrolled in school at least half-time. But you have an opportunity to gain exposures to science, math, engineering, computer science, and also administration. A specific way of volunteering is now, which is, I think, been in place for 3 or 4 years, is something called the SHIP program. And this is for high school juniors and seniors, okay? Who are high school juniors and seniors. They can apply to participate in the summer program for them as a volunteer with a NIST mentor. And you not only get SSL hours, but it's very, very competitive. There's a lot of students that apply for this, and less than half can get in because there's not that many positions. So I highly encourage this. This is a great program. So it's like a formal volunteer program at NIST for high school students. Now for college students, there's something called the Summer Undergraduate Research Fellowship, the SURF program at NIST. I know we're not talking about riding the waves, but this is a summer paid position, which Aki is in, so congratulations. And the SURF program has been around for many years, but what I want to say about this is that the SURF program allows the college students to come in and work with on exciting research projects with a NIST mentor, and they write papers and they do presentations, they attend seminars, and they get paid, okay, for doing this. It's funded by NSF, National Science Foundation. This year, I'm proud to say that we've had 13 applicants, a record 13 applicants from MC apply, which is amazing. And we've had 5 of those 13 actually receive a SURF award, including me. And that is a record, and that's amazing as well. Congratulations to MC and to the students who got it, and I hope this trend continues in the future. The applications are due for this, by the way, in February of each year. There's another program for graduate students that is funded by the National Physical Science Consortium. It's a graduate fellowship for people, for students who are interested in working on graduate degrees, and they're awarded a stipend in addition to getting their tuition paid for, and over 100 universities participate in this. By the way, I'm going to give copies of this to Professor Abdul and Mr. Mihalik and Dr. Kanamoy. And if you want any more information on this, please ask him. I'll ask him to disseminate this information, but I didn't bring copies tonight. Another wonderful opportunity in this is for postdocs, which are after you finish your PhD. That's maybe a long time for some of you, but in case you remember this talk in the future, if you ever get your PhD and afterwards you're wondering what you want to do, one of the good things to do, great things to do, is to apply for a NIST postdoctoral research associateship. And this is also a paid program, very nice opportunity, just like the SURF, but for postdocs, to work in this for 2 years. You get paid, and you get to work with a NIST scientists and in a very exciting research project. Now, this is highly competitive, and it's judged by the folks at National Research Council. But this is a great opportunity for those who are U.S. citizens, and you have to be a U.S. citizen, and you have to be a permanent resident, or a permanent resident. So if you are, and you get your PhD, and you in physics or chemistry or something like that, really try for one of these. It's really nice. And finally, there's something called the PrEP program, which is also an employment opportunity in NIST Gaithersburg. It's sponsored by the NIST Materials Measurement Laboratory, which means the research areas are focused on biochemistry, and biochemical reference data, and analytical chemistry. So it's in those fields. But it's also a great opportunity after you it's for undergraduate, graduate, and postgraduate, so college students. There's also a similar one in Boulder, which was actually established earlier, and they work with schools in Colorado. Just want to say a very quick few things on other opportunities that NIST engages with the universities and colleges, like Illinois College. We work with a lot of guest researchers. Over half of them are from academia, from universities. We have something called IPAs, which are intergovernmental personnel staff. So they're specially funded by some NIST and some other organizations. We also have quite a few facility users that come in and use our facilities, like at the Neutron facility, at the synchrotron facility, and also in the nano fabs. And then we help disperse also some grants to universities. So grants come in at least two kinds. One is the measurement science and engineering another kind called a precision measurement grant. So for colleges and universities are interested in this, I have some information here, but I don't think most of us need to know that at this time. Okay, and so in general, NIST works with academia in at least 3 different ways. One is by working with their postdoc students and guest researchers from universities. Another way is we work, like I mentioned at the beginning, we work with those 4 joint institutes and their staff. And then we try to help undergraduate and graduate students with those programs that I mentioned. So I just want to mention 2 other indirect ways that NIST is trying to help with the STEM effort. And one is the NIST webpage, which is NIST.gov or www.nist.gov, which contains a lot of information, including a lot of information about student employment and volunteering. So it's in there. And the second one are NIST tours. So I think we talked about this, this was mentioned before. But NIST does a lot of tours. So if anybody's interested in school, in middle school, high school, college, anybody in the public, actually, just contact somebody at NIST. You can contact me, and we'll try to get you set up to see any of these tours of the facilities that you are interested in. So this is part of the public dissemination of knowledge. So with that, I am done. I'm ready for questions. Any questions?
Any questions? Questions?
I have a question. You had on one of your slides altimeter or calibration. What is that?
Measure height in airplanes.
Oh.
Altitude, right?
Yeah.
Beyond that, I don't know what else to do with that.
Yeah,
It's very important, right? When you ride an airplane, you need that. Yes, yeah. There's a lot of stuff that just amazes me. Every time I help people go on tours, I actually learn a lot of things. So just ask. Questions?
How does NIST do all those different kind of projects? Do they have different subdivisions of labs, or do they have like contracts that they work on different projects throughout?
Both. So I showed you a little bit about the organization. So NIST is divided into physics, chemistry, engineering, IT, and nanoscience and other things. So that we have an organizational way of working on research projects. But we also do a lot of collaboration. We also have a lot of contractors, guest researchers, and other people who come to NIST that are not permanent staff, but they come and work at NIST. Any other question? Thank you.
Thank you very much.